All right, I'm going to get started for this next session. This is Julia Bosque-Gil, and she'll be talking about toward linked data native dictionaries.
Yes. Well, thank you, Jane. So, yeah, I'm Julia, and together with Ilan and my other co-author, Jorge Garcia, who unfortunately could not make it to eLex due to lecturing duties, we would like to talk to you about this idea of linked data native dictionaries, their motivation, what challenges we would be facing if we were to adopt a linked database lexicography, and yeah, our reflection and insights about this new line of future lexicography in the years to come. So, because there are people who were not present in those sessions that talked about linked data, I will go over the basics of linked data and the semantic web in 2 minutes. So, in order that you can understand the rest of the presentation, because otherwise it would make no sense. After that introduction, I will talk about the benefits of linked data to lexicography and what lexicography has to offer to linked data-based applications. And the core of the presentation would be the linked data native dictionaries, the vision, the impact, and the challenges we see, and then we'll finish with some concluding remarks on this. So what's linked data that everyone keeps talking about? You know that dictionaries come in different formats, in different, they are scattered throughout the web, they are developed independently, and they often contain complementary information, which very usually also differs in granularity. They are also hard to discover. If you don't know already the name of the dictionary you're looking for, it's hard to discover a new dictionary that is just out there. So we have this pool of scattered dictionaries throughout the web, and what the semantic web and the linked data particularly aims to do is to link all this information not only at the metadata level, but at the content level, dictionary entries, senses, forms, and so on. So how do we do that? How do we do this linking? We rely on semantic web formalisms, and one of the pillars of the semantic web is RDF, the resource description framework. From now on, during the presentation, RDF. So RDF allows us to define triples. And triples describe the semantics of the data. They constitute of a subject, a predicate, and object, resembling the sentential structure and the SVO typological order. And we have resources, so we have here Hansolo, and we can talk about a resource, we can describe it. A predicate is also a resource, and we can restrict what kind of arguments they take, and then there is the object, which can be a resource or a literal. So we can talk about the fictional world, like Star Wars, and we can describe language too. And we end up with graphs that describe entries, dictionary entries with their senses, with their parts of speech, and so on. And I want you here to notice these long identifiers are identifying the resource, the nodes, at a web scale. So these are the unique resource identifiers called URIs from now on during the presentation. And they are a key aspect when talking about linked data, because we have to use these kind of identifiers to talk about things. So we talked about these resources, the nodes. We have to define these unique resource identifiers in a way that people can go and learn about a resource. They can discover more things about this resource, and they can just navigate by moving through these URIs. So by linking and linking, we end up having a huge cloud of linked resources. These are resources from different domains that complement each other. And one of these domains is the linguistic domain. So we have here dictionaries, corpora, linguistic typological databases, and so on. Now, what do we gain by linking? When we link linguistic resources, we are able to, using the linked data paradigm, we are able to perform complex queries over multiple data sets. And why can we do this? Because they share they have syntax in common and semantics in common. And that semantics is provided by the triples, which are based on ontologies. So we can easily discover new data sets, and if I can easily discover something, I can also prevent reduplication of efforts, because I know that it's already there, so I won't do it. So this prevents the reinvention of the wheel in the development of new linguistic resources. So now you have an idea of what linked data is about, what the motivation is. what can it bring to lexicography? Well, first, we linked stuff. So the idea is to understand linked data as a common representation framework for lexicographic resources, which is linguistic theory agnostic. So if you are developing a resource with a lexical system based on the meaning text theory, or a resource that is based on the generative lexicon, if you are describing language, linked data could support it, no matter the lexical theory that you are basing your resource on. So because of the benefits that I talked about just earlier, the integration of information, the discovery, the easier discovery, and the interoperability, much of the work that has been done so far has been focused on converting already available resources to linked data. And what we are focusing now is on creating them in linked data from scratch. Now, what other advantages does this have besides linking to external resources, to external dictionaries? Well, linked data contributes to the reuse of the ingredients that you already have in your dictionary. I'll give you an example. Since everything that I have in my dictionary entry becomes now a node, as you have seen in the wood example before, I can easily point to these nodes. So if I have a usage example of a subsense, of a sense, embedded in an entry, that example is now a node in itself. So I can just access it and get to other points of the graph easily. So the reuse is a key point here. Imagine that I have this multi-word item, bow and scrape, which is defined in the Merriam-Webster as to treat someone who is powerful or wealthy in a strictly respectful way. Well, in some dictionaries, bow and scrape will be accessible through bow. Maybe it will be accessible also through scrape. Or maybe since it's our entry and it's not linked to the other two entries, all the combinations can happen. With linked data, we can not only link naturally to bow and scrape, but we can also link bow to the sense of bow that applies to this multi-word entry, and the sense of scrape that applies to a scrape in this multi-word entry. It's not that we could not do it without linked data. We could do it without linked data. But linked data contributes in reusing what you have already there, reusing those senses, because they are already there in the graph. We have another example with synonyms and cross-references. With K-dictionaries, we have a word in Spanish, meaning old-fashioned or old. Its synonym is not linked to anything, it's just there. This might be not the case in all dictionaries, but it could not happen if I have an ontology that tells me, if you have a synonym, you have to combine two senses. You have to link the stuff if you want to use the synonym relation. So it is this contribution of the stress is laid on the reuse of ingredients that you already have in your dictionary. There are other benefits I won't talk about here, but which are described in detail in the paper about design decisions and internal IDs and so on. So feel free to look at them or ask me if you are interested. Now, regarding the benefits of lexicography to linked data, Ilan and Jorge have been working on this part, and they discovered that there are some sections of the data that seem to be more valuable than others when they develop linked data-based applications. So for instance, the meta language, the DTD that you're using, or the schema that you are basing your dictionary on, seems to be very helpful when trying to see which linguistic vocabulary you want to link to. And the subject field or the domain of the entry is also very useful if you are developing word system equation systems. Other information like the free text or attributes don't seem to contribute that much when you are developing linked data applications. Now, what is the linked data native dictionary's vision? As you can now see, and I think probably already imagine, we refer to these two dictionaries that evolve, that are born and evolve dynamically on the web, following the paradigm I just told you about, the URIs and those principles that I show you. So they are graph-based, there is no node hierarchy, and the links across resources are naturally and easily established. Important point here is that they are compiled. They would be compiled as LD from scratch, not the result of conversions. So the result would be a vast network of interconnected lexical items that are connected through pragmatically and syntax and lexical, syntactic, pragmatic, and so on, relations that are defined in ontologies. So the semantics is provided by the ontologies, and then we just link things together with those ingredients that are provided there. So what would it mean to start creating dictionaries from scratch as linked data? Well, first, lexicographers would need to shift from a hierarchical view on the data to a graph-based view on the data. So they would need to start thinking about nodes connecting other nodes through predicates and which kind of restrictions those predicates will need to have. What do you have as domain? What do you have as range? In order to do that, they would need possibly a basic knowledge of linked data principles to play with different URIs, naming strategies to avoid collisions between dictionary entries. And they would need to see how they model the information in a way that everything that they want in the dictionary entry is there. Everything is there the way they want it, but at the same time, every ingredient is represented in a way that its reuse, its potential reuse is optimized. So the reuse is the key term that I will be repeating throughout the whole presentation, but because that's what linked data, it's one of the things linked data is about. So this is an example, a portion of the work we did with K-dictionaries, and I just wanted to show you that every part of a dictionary entry then becomes a node, and everything is connected through the edges. And this is only a part of an entry, but if you imagine a network of linked data dictionaries, it would be something like this, multiplied by 1,000, by a couple of thousands, actually. And you can just traverse and travel from one node to the other. Of course, we would need some tools and mechanisms to edit, query, and visualize this. And for now, there is no solid mechanism to edit and query and change linked data if you have no idea of the semantic web technologies, or no idea of Sparkle in this case, which is the query language you use to query these graphs. So this goes back to one of the questions that came up yesterday, and I hope that the eLex's project maybe will path the way towards this solution. The editing and the control of in the editorial process does not end here, because the quality of the data would need to be controlled too. And now, with quality, I know that there can be differences from one publisher to another publisher, or to an editorial team or another editorial team. But in any case, regardless of what they define as good quality, lexical information at the end would need to fit these 4 C's. It would need to be syntactically correct, so it would need to, the information would need to respect the RDF framework that we are basing on. It would need to be semantically correct. The ontology should be respected, and it should follow the ontology. Compact, because I don't want duplications in my data. I just want one information to happen once in my entry. I don't want repetitions. Complete, because if there is information about an entry, I want it to show in the entry. I want it to be everything in the graph, so I can just access it. And also logically consistent, meaning there should be no contradictions in my dictionary entry, and my dictionary entry should lead to no contradictions either. So we would need tools to evaluate the ontology that is working as backbone of my dictionary compilation system. And also we would need to evaluate that the instances of that ontology, so the actual data, actually are following that ontology and that are correct. Now, now that I have my model for linked data, I have my model for data for my dictionary, I have compiled it, I have created it. What do I link it to? What do I do? Well, as John was mentioning 2 days ago, BabelNet seems here as one of the resources that can be a promising idea if we use it as a pivotal resource to link dictionaries. And you cannot see it here, but actually in the linked open data cloud, there are already many dictionaries that are linked with BabelNet as pivot through them. There are linguistic vocabularies like OLIA or Lexinfo, for instance, that are also being used very commonly now. And so what to link to wouldn't be such a challenge. Now there are options. We have a more difficult problem if we think, okay, I have my cloud of linked dictionaries, they are all linked together. Now, as a user, I want to go and ask, and I want the cloud to behave as a single dictionary, so I can make a query that combines information from many different dictionaries, and I want a unified and unique representation of the information that is in those dictionaries. So how do I combine that information for my query? Well, that comes already into the data aggregation field, and we would need to deal with three processes here. Schema matching refers to the process of identifying elements that are equivalent in two different schemas. So imagine you have your dictionary as linked data, and I have my dictionary as linked data, but you have used a different ontology than the one I have used. Or you have used only part of the ontology I have used, but you have created your own elements, extending that ontology. So I would need to see which of your elements are equivalent to my elements as part of the schema matching, so I can combine the information in your dictionary with the information in my dictionary. Now, duplicate detection. We are dealing with lots of dictionaries. Of course, some information will be repeated in many of them. If I am the user and I want to ask something, I don't want the answer to be given several times if it's the same answer. So I need to detect duplicates across the dictionary cloud to make sure that I only get one answer. If the answers are in all dictionaries are the same, they share that value. Now imagine they don't share that value. Imagine your dictionary has information that is dissimilar with my information. I have to make sure that first it's compatible, and second, if it's not incompatible, maybe there are errors in one dictionary, or maybe even in my dictionary. So there are processes that in the data fusion realm that make sure that these conflicts are either avoided or are solved. So imagine that I have an entry, and in my dictionary I say that it's a noun. In another dictionary, it's said that it's a proper noun. So they are compatible, they are both nouns. But I have to make sure that these values these values are just differing granularity. So it's not the it's not the same. If I have a noun and a verb for the same entry, for the same sense, there is an error there. So there should be strategies to see what to do when different values are found to see whether they are compatible or not. And then you combine all the information and you get a unique representation of that answer. So key points to bring home. Linked data allows both to enrich the lexical information in your dictionary with the lexical information in other resources external to yours. Point one. Second, by adopting graphs, it's very easy to reuse the ingredients that you already have in your dictionary, because everything that was embedded in an entry has now become its own node. And by using URI naming strategies that are transparent, we can intuitively link to those elements without need to rely on internal identifiers. Now, we have interoperability across resources and NLP tools because we have these shared semantics and syntax. And of course, because things are more easily discovered, we gain invisibility. As developers of dictionary, our product gains invisibility. So we would like to think of LD native dictionaries as a possible future step in which lexicography could evolve. And it would be, those LD native dictionaries would be aimed from the very beginning at both humans and machines, not as humans and then converted into something that is exploited by machines, but aimed at both from the beginning. The entry structure, because it would need to be, again, revisited, seeing whether it matches or not my model, how to model everything in a graph structure would need to be revisited. And also the expected skills on part of the lexicographers who would need to have an idea of linked data principles or would need to get acquainted probably with with URI naming strategies. And of course, we would need, if we don't want to rely on semantic web technical knowledge, tools to edit, to query and visualize the data that I am creating would be needed. And of course, tools on the back end that control the quality of the data and the quality of the aggregated data if I am performing a query and I want a unified answer. So this is the idea, and I will be happy to ask and to answer any question that you may have. That's it.